question 10. So we're looking to find the coefficient of x to the 11. That's that number in front of x to the 11 in a long expansion. We are expanding x squared plus 1 over 8x to the 10. Find a if the coefficient, oh, we don't, sorry, my mistake. We know that. That's 50. Okay. We don't know is a. Anyone think they know what a is? 9.5. Lucia? No. 20? No. Lucia. God. Sorry, Lucia, go for it.
Just the answer?
Yeah, just the answer. 2. And anyone disagree with 2? Okay. Anyone want me to do it? Okay. All right, so the key here is trying to find that x to the 11th term. I don't want to spend all day and do the whole expansion with a load of a's in it and x's in it. So I'm going to restrict myself to trying to find which term I'm looking for. For this, one method is to just go straight to a general term. I know that there's 10, it's the power of 10, so 10 would be here, and there's going to be 11 terms, which is power of 10. Okay, the first thing in the binomial is x squared, and the second thing is 1 over 8x. Okay, so by its binomial, there's 2 things. All right, so it's about a combination of these 2 x's, x squared and dividing by x in their different powers that they're going to be put to the power of to form x to the 11. So let's just do that as an aside. Okay. X squared, and x squared is eventually going to be divided by whatever the x power is. Does that make sense? So when they're combined, what happens is, in general, that is x to the 2 take away 1. That's just the rule of indices. I haven't done anything to the powers yet, and that will give x to the power of 1. That's the way indices is going to work. So let's think about it. We want to make x to the 11 out of the top one, x squared to some power, divided by the bottom one, x to some power. Now a doesn't matter at the moment because a is not a variable, it's a number. It's going to just be an answer like 2 or 3 or something. All right. These 2 numbers have to add to what? The powers here and here have to add to what? 10. 10. When they were worked out, they will eventually have to be x to the power of 11. Yeah. Okay. So let's guess. Let's say, make this one 9, this one 1. All right. 9 and 1. Does that give me 11? Well, it's going to be 2 times 9. That's the way indices work. 18. Take away 1. 17. I'm way off. I want x to the 11. All right, so let's pick 2 different numbers. Matthew, give us an
7 and 3.
7 and 3 because you know it works, or because you're guessing? Let's try 7 and 3. Let's see if you're right. What an inspired guess. 7 and 3. So this is 2 times 7, which is 14. Take away the 3. 14 times 3 is 11.
Okay.
Which is what we want. We want 11. So it's about the combination of these powers. This one is doubled because of the x squared. So now I know that this is correct because it's the x to the 11 term. Which means that if that is 3, this is 3. And that's the way it always works. So 10 choose 3 on a calculator. Did anyone get that?
120.
120, thank you. That is 120. The x's don't matter really much anymore, but we can work them out if you want. That's x to the 14, isn't it? And this is going to be 1 over, now, it's going to be ax cubed. The way I'd write that is a cubed x cubed. Like that. Yeah? If I combine that together, this for the 14 take away 3 is going to make 11. X is 11 all over a cubed, 120, something like that, equals 15, yeah? So, how do I solve this? The x to 11 doesn't matter because this is 15x to 11 as well. So we're just looking at the coefficient really. So 15 is equal to 120 over a cubed. So it's just an algebraic solution here. Multiply both sides by a cubed, and you get a cubed, 15 if you want to do this step, 15a cubed is 120. Sometimes you talk about cross multiplication here. Divide by 15, both sides. 15 fits into 120, well 30 would be 2, so 2, 4, 8 is it? And then a would be the cube root of 8, which is 2. And that is how you do it first. So well done to those who got it right. These are difficult. This would be as hard as they're going to get, these 3 questions. Okay? All right, whereas 11C you had as well? Was this worse? This is worse. Okay, that's not good. That was hard. All right. Find the term containing x6. So x6 term, whatever that is, in this expansion, 2 minus x. Oh, it's something times something. 3x plus 1, 9. Okay. Anyone think they have an answer for this? Nobody? Okay, drawing it back. Any idea what I do first? Panic? Looks tricky. Well, I'm only looking for one particular term in what would be probably quite a large expansion here. This has 10 terms in it alone. And then you're multiplying 8 by 2 terms. So there's going to be loads of terms. How many terms do we think there are going to be? If this has 10 terms to it, and you multiply them by these 2, 20?
No, I don't know.
I think it's probably going to be 11, just 11. Because all the x squares will combine, might be another, and it's going to be, for an example, the x squared will become an x cubed when you multiply by this, and there already will be an x cubed there. This will just be all the same numbers again, so they're going to combine. There will be 20 terms, but they'll all simplify back down to 11 terms. There'll only be one new term, one new power. Anyway, that didn't help. But what will help is if we think about what term we're looking for. X to the 6 will come from 2 places in the expansion. It'll come from, when I multiply this out, I'm going to have something with x to the 6 in it, and something with x to the 5 in it. Why am I looking at those 2? All the rest, they're going to be beside each other. All the rest I don't care about. Anyone figured out why I only care about those 2?
Because one will multiply by 2, so that's still x6, but then one will be multiplied by x.
Exactly. So it's going to be multiplied by 2. So the 2 is going to run through all these 10 terms. I'm going to multiply them all, double them all. The only one we care about it doubling is this one. So it's going to stay something to the power of x to the 6. This is going to run through all these terms as well, all 10 of them, and increase their power of x. The only one that will matter is this one, because it'll get to x6. All the rest of them won't get to x6. One will go to, the one previous will go to x7, the one before will go to x5. That's the only one that's going. So there's only 2 terms we need to find. We need to find the x6 term and the x to the power 5 term in this expansion. Okay. And then we can multiply it by these 2. But so that solves part of the problem. So now we need to go and use the general term to find those two terms. 3x, 1. Okay, I'm looking for the x6 term here. I'm going to look for the x5 term here. Okay, I can start to fill in some stuff. How many terms, or what's the power of the expansion? 9, you happy with that? I can put in 9 here and here. Yeah. If I'm looking for the x6 term, the only thing that's going to give me x to the power 6 is if I give it to the power 6 here. Which means that's 3 there. Which means that is 3 here. And the only thing that's going to give me to the power of 5 here is 5 here. Which means this is 4, this is 4. These are two terms, one after the other. So we presume positive. This one's going to come out positive. There's no negatives to make. There's no negative anywhere in this part of the binomial to make it negative. So now we take out our calculators. We do 9, choose 3. I don't have my calculator ready. What's your organization? 9, choose 3, and 9, choose 4. Or you can draw the 9, choose 3 is 84. Okay. NCR, so that's 84. Okay. Oh, I need to do 3 to the power 6 as well. But anyway, 9 choose 4. More than that, 126. Okay, that's 126. 3 to the power 6. 343? No. The next one, 729. 29x to the 6, and 1 doesn't matter, that's gone. And then the next term is going to be, that's the 343, is it? No, it's not 343, it's 243? 243. And x to the 5. Wow, okay, big numbers. Well, you have to multiply these out, unfortunately, but you have a calculator, so that's okay. 84 times 729?
61,236.
X6 plus 126 times 243? That's
30,618.
excellent, fine, cool. So this is a big, long expansion. We've only found 2 terms in it. Now, you could have done the whole thing. You know, if you were stuck with ideas, you just do out the whole expansion. You should have the ability to expand this whole thing. But we only needed 2, because they're going to multiply by 2 and x. So which one's multiplied by which again? The 2 will be multiplied by this, and that's the only one that matters, so double that. And the x is multiplied by that. So this one is 30,618 x6 when it's multiplied by the x one. This when multiplied by the 2 is whatever. 2, I'm not going to do that in my head. It's easier, 122,472, is it? What's this doubled? 122,472.
1, 2, 3, 4, 7.
Okay. And then you can add those 2 together, add the 30, oh jeez, 30,618. Is that the right answer? Does anyone know?
Isn't it because it's minus x over here?
Oh,
Uh-oh.
it is subtraction, yeah, I would have got it wrong, thank you. So that's, I multiply by x, it's minus x. So that is a plus, but it's multiplied minus, thank you. And I subtract, and that's not the right answer.
I've got 91,854.
Is that the right answer? Has anyone checked? It is? Sweet. A very difficult question. Very difficult. thought the first one's hard. That is really difficult to get there. But hopefully you understand the concept of not getting the whole expansion, just picking what terms I want and then trying to find them using the general term. Okay. Next one. Question 12. So we already discussed what n element of z plus means briefly. It means positive integers. Z stands for integers. So what it's saying is it's a positive whole number. And get used to that kind of terminology. They almost put it there just to confuse you. Yeah, you know that it's going to, because you haven't done anything other than positive numbers to the power of n. And you won't be doing anything other than to the power of positive numbers in SL. So it's pointless them even saying it because you know it's going to be a positive number. Anyway, find the values of k and n. Okay, let's get stuck into this one, and then you guys are going to be back doing some maths yourself. Was this easier than the last one? Or are they all equally difficult? All difficult. This one might have been slightly easier. Anyway, I haven't done it yet, but maybe that last one was really hard. Kx the n is. So it's starting off this expansion for you. Plus 60x squared, and so on. I'd actually said the next one's minus, but. General term, I suppose, seems to be our friend for most of these. Anyway, an answer for k and n? No? No? No. Okay. Is the first term any good to us? Well, let's just split them all off into their general terms. I may have made that a little bit big because I'm out of space. I'm going to put it over here. N. What goes here? With the first one? 1? Is it 1? Oh, maybe you're not sure. 1 goes there anyway, and we've got kx. We'll come back to that. Plus n. Not sure. 1. Kx. Well, I'm not putting anything in yet. I'm just doing the general term. Just the two things, the binomial and n. And then that's n. 1 and kx. We don't know what power is yet, and we can maybe figure out some other stuff. Okay, you should be able to do that. I'm just setting the whole thing up. All right. What's here? Is it 1 or is it 0? Ah. 1? 1 kind of makes more sense, isn't it? This first term should be 1. Yeah, well, you could learn it like that, but you can think about what is the first term here. It's this times this a load of times. This term doesn't even exist in it. Think about it that way. The second term doesn't even exist. It starts counting at 0. Remember? So that's going to be 0. Then the next term is 1. Then the next term is 2. And that corresponds to the power here, because of course that first term doesn't have an x in it, so it has to be the power 0. This one has a 1 in it, and this one would be squared. Okay. The n power here works the same way, but in the opposite direction. This starts to the power of n. And then it'd be n what? Oh no, don't put it there. N, what's that one going to be? Minus the 1 from here, and this is going to be n minus the 2 from there. All right. Things are starting to improve. What about this 1 to the power of something? It doesn't really matter what it's to the power of. You power of like 1 billion, and it still would be 1, wouldn't it? So I'm happy enough just kind of saying that's 1 from now on. Don't need the power. So just 1. How much is this going to tell us, this first term, about this? I don't think it's going to tell us anything because there's no information. It doesn't end up being multiplied by anything to get this answer. It's just this one. So this is not really going to tell us very much. These two are going to tell us everything. And the fact that there's two is starting to tell me that there's going to be two equations at the end of this, and I might have to solve them together, possibly. Because there's two answers, means there might be two equations involved. Simultaneous, perhaps. Anyway. This exponent, that's an issue. I don't want it in this form. I don't like that form. It's very hard to solve for n in that form. We had an example like this yesterday. What did I do? Laura? I used something. I used the factorial thing, isn't it? What's the factorial thing? It's n factorial. I'll just put it up here. So we have n factorial divided by n minus or factorial times the or factorial. And n, all right. This is tough, very last lesson of the day, isn't it? Okay, let's change that into this form. N factorial, n minus 1 factorial, 1 factorial. Simplify now. N minus 1 factorial. The next one's n minus 2, the next one's n minus 3. This one, the next one's n minus 1, all the way down. So this simplifies down to n. Or, well, I know it was just n, isn't it? Anyway, 6 over 1 is just 6. Do we see that happening? Do you want me to do that out? N factorial is n minus 1, n minus 2, all the way down. The bottom line starts at n minus 1, n minus 2, all the way down. These start cancelling off, all the way down. All you're left with is n. And 1 factorial is just 1. So it's n over 1. Well, that looks a lot better. Let's rewrite this term. It's n, plus I'll just write it underneath actually. I'll do the coefficient over here. But that's n. Oh, is it just n kx? Is that okay? Can I write that, n kx? Does it make sense? Yeah, well, n is going to be a number, k is going to be a number. When you multiply them together, you get, negative 12. N times k. So what can I glean from this? N times k is negative 12 from this piece of information here. I know the x is there. Okay, that's something. That's one equation, two unknowns. Perhaps I need to find a second equation, which I can't from the other thing. This maybe be a bit faster. N, choose 2. Oh, it's not as easy as n over 2 though, is it? Because n minus 1 started here and cancelled out that n minus 1. Now n minus 2 doesn't start, it starts here. That's still left behind. These two are still left behind. So what we're left with in this one is n times n minus 1 all over 2 factorial. It's not 1 factorial, it's 2 factorial this time. This is all cancelled away, n minus 2. Perhaps I need to write that. It's n factorial all over n minus 2 factorial times 2 factorial, or is 2. Okay? And these first two terms are left behind, and all the n minus 2 down cancelled. 2 factorial is just 2, because 2 times 1. All right. This can be rewritten as well, n squared minus n all over 2, yeah? So like a fraction-y thing. That is going to be times by what? By 1 and by... So I can replace that. That's that. Times 1 times k squared or k? K squared, yeah. K squared, was that equal? 60. That's that term. Wow. N squared minus n over 2 times k squared equals 60. There is my two equations. Even solving this is going to be difficult from here. I think. Well, let's do it. Let's look at this. I'm going to simplify this first. I think if I multiply in the k squared, and it's going to be n squared times k squared minus nk squared equals 120. Multiply both sides by 2 to get rid of the division by 2. Okay. And my other one is just nk equals minus 12. Any ideas how to solve this? They're simultaneous equations, but we're not going to solve them simultaneous equations by elimination, where you line them up and multiply. Good idea. So this will be then 144, is it? Squared. What's the problem here? That's n to the power 1 k squared. It's not the whole thing squared. That's the whole thing squared. So it won't sub in here and here. You wouldn't want it to sub in because then it would be 144 equals 120. That doesn't work. Huh?
The second equation would make it equals n.
So simultaneous equations solved by substitution. N is equal to minus 12 divided by k. Put the k back in with the number. Now we have a representation for n in terms of k. So put this in instead of that n, minus 12 over k times k squared times k squared. Instead of this n, minus 12 over k times k squared equals 120. So now I've combined those two into 1. Minus 12 squared is 144. K squared, that's going to be k squared down here. So it's going to be 144 k squared divided by k squared. Happy with that? Maybe. Minus times minus gives a positive. That's just going to be 12 k squared over k. There's nothing to square this one this time. And k fits into k squared once, so we're just left with k equals 120. So I have 12k here of 144. Let's bring this over here or subtract it from both sides. 12k is equal to 120 minus that 144. That's negative something. 24. 12k is equal to negative 24. Divide both sides by 12, and k is equal to negative 2. Finding n now should be pretty easy. If k is negative 2, I know that this k is negative 2, so n is 6. You can sub it back in if you want. N is equal to minus 12 over k, and then it's equal to minus 12 divided by minus 2, which is 6. And we found n. What was the question? Finalize your k at n. I don't know if that's right, but if anyone checked the back, hopefully it is. Okay. Yeah, that was harder than the previous one. The previous one was hard. So realistically, if you're like aiming for a 7 in this course, that'll still be difficult. That'll be one of the more difficult questions on the exam. you're aiming for a 7.
How many marks did you get for answering this question?
That's a good question. There was no calculator involved, so the paper split up interestingly. The paper goes about 7 short questions, 3 long questions, and the 7 short questions get progressively harder. The first short question might be worth 6 marks, and the last of those might be worth 8 marks. But you'll spend 2 minutes on the first one and maybe 15, 20 minutes on the last one. So realistically, this is probably worth about 8 marks. But it'll sort out the people who are between, 6 and 7, rather than people who are trying to get 4. If that makes sense. So it won't be worth as many marks as it possibly should be. Okay. I don't know if that helps. Yeah. It could, realistically, it'll be 3 times as hard as the first question, but not worth 3 times the mark. So they set you up in the exam. The first 2 or 3 short answer questions are gimmies. They're obvious. They should be obvious. And then they get harder and harder. And the last one, question 7, is usually a really difficult one like this. Then they do 2 or 3 long questions. The first one will be easier than the second one. So that's the way to set up. You should know going into the exam. Perhaps I'll do question 1 to 4 first. Then I'll do one of the long questions that looks easier to me. They mightn't always put the long questions in the easiest order. They always put the short questions, and then come back and look at the hard questions. Because they will try and stump you. They don't hand out 6s and 7s easily. They hand out 3s, 4, and 5s easily. Not easily, but you know what I mean. Okay. All right, you've got to do more. But let's have a look at the types of questions that come up again. So this is just the review set at the end of the chapter. I'll just take in some of the questions. This, 3, 4, and 5 have come up in exams. Questions like this have come up in exams, where you just have to go straight to finding a particular term, or to find the entire expansion, which should be on the easier end of the scale. Now that you have done these ones. Okay, so this might be like question 1, 3, 4, and 5, and 6 and 7 might be like a question 4 or 5. That one you just did is like a question 7 in the exam, so different. Really. So get stuck into these. I'm not telling you to do a specific amount today. Just pick one that you think you can do and do it, or pick a couple. You got what? 20 minutes left. You should be able to do a couple. If you want to go straight for the more difficult ones, go for that. These should be straightforward. If they're not straightforward, you might need to put a bit of extra work into this before next week. So we're going to finish off with binomial theorem today and tomorrow, and then we're moving backwards to sequences and series. Again, Julian.
Are we going to have a class?
Yes.
Why?
So we're going to do sequences and series all next week, and then the following week you'll have your exam. So the exam is going to be sequences and series and binomial theorem altogether. So sequences and series is stuff we did at the end of last year. Yes. Is that exact question?
No.
No. But this exact question, or this type of question will be like the last question you'd attempt in the exam, not the first question you do in the exam. It's like the challenge question towards the end. It's like, if you have time, you could maybe be able to solve this. But these are the questions that will get you to pass. These are the questions that get you a 7. So make sure you can do these first. These will get you 3s, 4s, 5s. Okay, I'm going to stop recording and you're going to do some work. So guys, if you can't see this and you're online, it's the review set at the end of that chapter 1. And you can just work on it. You don't